Now that we have a graph of the position of a car on a road, let's analyze it in various intervals to see what information we can obtain from the graph. So let's take a look at this interval. Let's look at from 1 second to 2 seconds. So in this 1 second interval, the car's position changed by exactly 10.00 meters. So what was the average velocity of the car in this interval? Remember, it's an average velocity because the interval is measurable. Well, we moved 10 meters in 1 second, so the average velocity in the interval is 10 meters per second. Let's analyze another interval. Let's look from 5 to 7 seconds. So in this 2-second interval, the object's position changed by 20 meters. So by the same analysis, we can see that the average velocity is the displacement of 20 meters over 2 seconds, which is also 10 meters per second. You should easily be able to see that any interval chosen will yield the same result, 10 meters per second. Mathematically, what were we doing? If you look at these little intervals, this is the run and this is the rise. So the definition of rise over run, if you remember from your math courses, is the slope of a line. So the velocity from a position time graph is always indicated by determining the slope of the line connecting the points. So remember, you always need 2 points when you are taking a slope, because the definition of slope, rise over run, which is in this graph, the change in x over the change in t. Notice we're not writing it as change in y over change in x. This is the change in the vertical coordinate divided by the change in the horizontal coordinate, which is x2 minus x1 over t2 minus t1. So by picking any 2 points on the line and finding the slope, we can determine the velocity of the object in that interval.